Electrophilic aromatic substitution is an important class of organic reaction in which an atom on an aromatic ring, most frequently a hydrogen, is replaced with another functional group. For this specific reaction, the exact mechanism is not known, but it is assumed that it is facilitated via a Lewis adduct formation between bismuth nitrate pentahydrate and the solvent or substrate that generates the activated nitronium electrophile. During this reaction, the electron-rich aromatic ring performs a nucleophilic attack on an activated electrophile. An addition of the electrophile into the aromatic ring occurs, temporarily losing aromaticity and forming a series of carbocation intermediates. The elimination of a hydrogen atom restores aromaticity to the newly substituted ring. In this particular reaction, we will be doing a highly non-traditional nitration of thymol using the reagent bismuth nitrate pentahydrate, resulting in a mixture of mostly mononitrated thymol derivatives with some regioselectivity toward para-nitration. This mixture of products, as well as any remaining starting material, will then be purified via column chromatography in the subsequent lab period. You can read about the background science of column chromatography in the lab manual and the background information posted online. These are the items that you will need to run the electrophilic aromatic nitration of thymol: a 25 ml round bottom flask, a 10 ml graduated cylinder, a TLC chamber and TLC plates, a 25 ml filter flask, a Hirsch funnel with frit and vacuum adapter, thick-walled tubing, a small beaker, a scintillation vial, and a crystallizing dish and thin-walled tubing for evaporation. Obtain 0.15 grams of thymol and 0.201 grams of bismuth nitrate pentahydrate. Combine these in a 25 ml round bottom flask, and then add 4.2 ml of acetone to act as the solvent and begin your reaction. Make sure that you are using acetone that has been freshly dispensed from the pump in the yellow solvent cabinet instead of the bottle in your fume hood, to ensure that it's as dry and free of impurities as possible. Using a small stir bar, vigorously mix the reaction at approximately 1000 RPM. Make sure that the heating function on your hot plate is turned off. Make sure that you are ready to monitor the reaction by TLC. The mobile phase is 20% ethyl acetate and 80% hexanes. This is pre-prepared for you in the distribution hood. You should prepare 3 full-length TLC plates, one for each potential time point of the reaction, so 15 minutes, 30 minutes, and 45 minutes. Each plate should have 3 lanes: the thymol standard, the co-spot, and the reaction mixture. It's now time to monitor the reaction by TLC. A TLC standard must be prepared of thymol. Prepare a small amount in a shorty vial by covering the bottom of it with thymol and dissolving it in acetone, about 1 to 1.5 ml. At 15 minutes, stop stirring the reaction mixture and allow the solids to settle out to the bottom. Dip the capillary into only the organic layer above the solids. On the TLC plate, be sure to spot the reaction mixture in both the co-spot and reaction mixture lanes. The thymol standard should be spotted in both the standard and co-spot lanes. Turn the stirring back on once you're done, and develop the TLC plate in your TLC chamber. Evaluate the plate under the UV lamp once the plate is done developing. Once the reaction has reached completion by TLC, there will still be a small amount of thymol remaining, or the reaction has run for 45 minutes, whichever is faster. You will filter the reaction mixture in order to isolate the crude reaction mixture. Prepare for vacuum filtration by setting up a 25 ml filter flask. Unlike the previous vacuum filtrations that you've done, you'll be using the Hirsch funnel instead of the Buchner funnel. The Hirsch funnel should have a filter for it already in place. Next, add Sealate to the funnel until there is a reasonable pad built up, and turn on the vacuum. Sealate is a filter aid that is absolutely necessary for filtering this, as the solids in the reaction mixture are very fine and would just pass through and/or clog a filter paper. Swirl your reaction mixture and pour it into the Hirsch funnel. Rinse the round bottom with another 4 to 5 ml of acetone, and also pour this into the Hirsch funnel to try and transfer everything. Pour the filtrate into a small beaker and add anhydrous sodium sulfate until the bottom of the beaker is covered. Allow this to dry for approximately 10 minutes, and then decant the reaction mixture into a scintillation vial. Wash the sodium sulfate with multiple small aliquots of acetone until the sodium sulfate is very pale in color. Prepare the reaction mixture for evaporation by clamping the scintillation vial into a warm water bath and evaporating with a gentle stream of nitrogen. Be careful with the nitrogen flow rate, as acetone is water soluble, and you will not be able to isolate your crude product from the reaction mixture. After evaporation, cap your scintillation vial and store in your drawer until the next lab period, where the reaction mixture will be purified via column chromatography.